The atomic number tells us how many protons are in each element. That's the atomic number, the number of protons. This number is found above the element symbol on the periodic table. So down here in the picture, you'll see here's an example of hydrogen. The number above is the atomic number. So hydrogen has an atomic number of 1, meaning it has 1 proton. We know in an atom it is chemically neutral, so the number of protons equals the number of electrons. So since hydrogen has 1 proton, and we know in a neutral atom protons equal electrons, we know it also has 1 electron. Gold, just picking another random element, has 79 protons. I encourage you to look at your own periodic table. How many protons does oxygen have? If you want to pause the video. And how many electrons does oxygen have? Hopefully you found that oxygen has 8 protons, which means it has 8 electrons. We move on to isotopes. This was one of the ways that John Dalton was wrong in his theory. If you remember, he said atoms of an element are all the same in size, mass. Isotopes are proof that he is wrong in that part. Isotopes are atoms of the same element that have different masses. So you can take oxygen, for example, as you see below. Oxygen has different atoms that have different masses. They don't have to be different, but they do have isotopes that are different. What's different about them, or what makes them different masses, is the number of neutrons. So every oxygen atom has 8 protons, always. You'll see down here, 8 protons, 8 protons, 8 protons. That won't change, but the number of neutrons can change. So you'll see here, 8 neutrons, 9 neutrons, 10 neutrons. So one with more neutrons, as you can imagine, would have a higher mass. That's what an isotope is. Now, how do we determine how many neutrons an isotope would have? We use something called the mass number. The mass number is the sum of the protons and the neutrons. That's what the mass number is. There's 2 different ways that we can illustrate or write isotopes, and we'll see that on the next slide. 2 methods. The first method is called hyphen notation. Hyphen notation shows the element name, a hyphen, or just a dash, and then the mass number. So the number after the dash is the mass number. So here in hydrogen 3, I see the element I'm working with is hydrogen, and I see the mass number is 3. The other way is called the nuclear symbol. Now, a little bit of formatting issue here. This 3 and 1 should just be right next to the hydrogen and not up here. So you'd want it 3, 1. It doesn't have to be up like superscript. The number at the top, the 3, tells us our mass number, and the number at the bottom, the 1, tells us our atomic number. Do we need to know, or do we need to be shown the atomic number? Do we need to be shown this number 1 here? We don't if we have our periodic table, because we can find the atomic number from the periodic table, right? I see that it's hydrogen, so I can just look for the number above H on the table and it'll tell me the 1. But if you don't have access to a table, that's when the nuclear symbol is helpful. So, just recapping that. How do we find the number of protons? The atomic number, right? We look at the periodic table there. So you could just say periodic table. You're not expected to memorize that. How do we find the mass number in these isotope problems? Well, a lot of times it's going to be given to us, right? In both of these notations, mass number is given, mass number is given. How do we find the number of neutrons? Here is the formula. So neutrons equals the mass number minus the atomic number. Or we could say protons here. Knowing this formula, you can solve for whatever you need to. I actually like to write it out this way. That the number of protons plus the number of neutrons equals the mass number. And then if you know two of them, you can find the third. Very basic addition or subtraction. So I have a slide here practicing. I'd encourage you to do this with me. I know you can see the answers, but make sure you know how I'm getting to those. So how many protons, electrons, and neutrons are in an atom of chlorine-37? I could word that question. How many of the subatomic particles are in an atom of chlorine-37? Same thing, right? Protons, neutrons, electrons are subatomic particles. So what do we know? We know the mass number here is 37. Looking at my periodic table, above chlorine, I see the number 17. That tells me my protons. My protons always equal my electrons in a neutral atom, so electrons will also be 17. My neutrons, I have my formula. I'm just subtracting 37 minus 17, and I get to 20 neutrons. Here's a practice problem you can do on your own. Just hide the answers and then check them. Also, what I would like you to do is to, separate problem, write the nuclear symbol for C13. That's the other notation, nuclear symbol. And we can check that in class. There is a meme for you. And lastly here, the average atomic mass. This is the number that you see below the element symbol on the periodic table. It's a decimal number. So how do we arrive at that decimal number? What that is, it's the average, it's the weighted average of all of the atomic masses of the isotopes. So for hydrogen, for example, we have an isotope of hydrogen 1, we have an isotope of hydrogen 2. You would be given what's called the percent abundance, how much in the real world is hydrogen 1, and you can see most of the hydrogen in the real world is hydrogen 1, 99.9885%. Hydrogen 2, very little in the world. I believe hydrogen has 3 isotopes. I'm not entirely sure. I don't know why only 2 are shown. I could be wrong. But some elements have 7 isotopes or 8 isotopes. It just depends. And then you have this atomic mass for each isotope, which you'd also be given. This is the number you see on the periodic table. So how we find that is we multiply these numbers by these. Let me say that differently. We would take this 99% and we'd get it out of percent form, right? We'd move the decimal 2 places to the left. And we multiply that by the atomic mass of that isotope. Okay, so I multiplied this by this. And we're going to add that to the product of this and this. Make sure you get it out of percent form. And that will equal our average atomic mass. That's how you find that number on the periodic table. This is just the word form of what I've just said. Okay? And then there's an example here for you to try with the answer given. So make sure you can get to that answer. So try that problem.